Next, let us look at how to get the transformation matrix of an articulated configuration. Articulated configuration is one of the five basic configurations of robotic arm that we have studied in the first module. So, how do we write the transformation matrix of this articulated configuration? The structure is already drawn here, and here the one of the difference that you will see is that we are having this L1, L2 and L3 distance mentioned here. In previous cases we have never mentioned, so this is just an example of, suppose if we are having a length mentioned here. So let's try to find out. So first is we have to draw the z axis for each and every case. So let me choose the correct ink for it. Yes. Okay. Next, we are going to start with the axis for this one. For the first joint, it's going to be in this direction, because that is the direction, that is the axis, direction of the axis in which it is rotating. So that I can name it as Z0. Let me change the color. So here it will be Z0. This is Z0 axis. Similarly, for the second case, I will draw the axis in this direction. So that will be Z1. Similarly, for the third joint, which is again a revolute joint itself, I will again draw the axis in this direction. So that will become my third axis, which will be again it is going to be Z2. Now next I have to draw Z3. Generally it might look all good that, if I'm going to draw Z3 something like this in this direction, if I'm going to draw it like this, just to follow up how I have done it previously. But the issue will come is, how will I draw my x-axis? Because then there might be certain confusions that will arise. So what I will do is, for making the link parameter table very simple, I will try to make the direction of the z-axis of this end effector in this direction. So let that be my z3 direction. Okay, so that is z3. Now coming to the x direction. For x direction, we all know that I will start always from here. Before that, I have to just take this one slightly inside, otherwise I will not be meeting the origin correctly. So that is my z1. Similarly, this one I will take it a bit inside and then elongate this one. Okay. So next, z0 and z1, if you see, both of them intersect at this origin. So I will draw the x-axis for this particular frame in this direction. So that is going to be my x1. So let me draw my x1 frame. So I will draw my x1 frame here. Based on that, next I will draw the frame for the lower joint. So this will be x2. So not x2, x1, x0, sorry. So I will draw this as, I will write this as x0. Similarly, here z1 and z2 are parallel. So the common normal, I can draw it anywhere. According to DH convention, it is best to draw it in the same direction as the previous one. So I will draw it in this direction. So this will become x2. And then here I will have to go for the intersection of z3 and z2, which will basically now happen here somewhere. So I can draw it perpendicular, because there is a length L1. I will have to draw z2 and z3 are lying in this particular plane. So I will draw z3 perpendicular to that, x3 perpendicular to that. So I can write this as me write this as x3. So now all the frames are ready. Next I have to fill the link parameter table. So let's go from the 0th frame to the first frame. For making it parallel to x1, here it's already parallel, but we are having a link variable here, so I will write this one as theta1 star. Then how much distance I have to move in z0 direction so that so that this frame 0 reaches frame 1, that is given by this length L1, so I will write di or d1 is length L1. Similarly, once I reach there, how much an I have to go so that x0 and x0 and x1 overlap. They are already going to be overlapped, so this is going to be 0. Next, x0 to make it in the direction of z, so I will have to go anti-clockwise, no, clockwise, so it is going to be minus 90 degrees. Going from the first frame to the second frame, going from frame 1 to frame 2, that is x1 by z1 to x2 z2. So here already x1 and x2 are parallel to each other, but there is a link variable, so I will write that as theta2 star, and then d is the distance I move in z direction so that both of them are collinear. Here both of them are already collinear. X1 and x2 are already collinear, so I will write it as 0. How much in x direction we have to move so that x1 and x2 overlap, that is ai, so that distance according to the diagram it is going to be L2. Once we do that, we can already see that z1 and z2 are overlapping, so alpha I will be 0. There is no movement required. The third one, again, to make x2 parallel to x3, I can write a 90 here, but since I am already having theta 3, so I will just write theta 3, and then imagine that x2 and x3 are in the same direction. Then how much I have to move so that x2 and x3 are both parallel. Now here is where a mistake has happened, and that mistake has happened because I didn't look at one of the DH conventions. If you remember, DH2 says that whenever you are drawing the x-axis, its previous z-axis should intersect with the x-axis, the present x-axis, at some point. If you see x is in this direction, going up and down, z is in this direction. So we can clearly say that x and z are not going to intersect at any time. Both are lying in a different plane. So DH2 is not maintained. So what I will do is I will go with the other rule, that I will have the z direction in the same direction as the previous frame. So based on that, I will try to draw z3 again in the same direction as the previous case, because this is the end effector, and then we go for this one as z3, and then x2 and x3 again I can draw it in the same direction. I will draw it in this direction, so this will be x3. So now it's all okay. Now if I'm going to look, x3 is going to intersect z2, that is the previous z axis, at this particular point. So this choice of axis is very correct. So now DH2 condition is satisfied, so we don't have to worry. So now if I'm going to write the last row based on that, then I can write, let me select the pen. Okay, so how much distance it has to move in z direction, there is no need because it's already collinear, so it is 0. Next, how much it has to move in x direction so that x2 and x3 overlap each other. That distance will be L3. And finally, Z2 and Z3 are overlapped, so this one again becomes 0. So now that the link parameter table is completed, what we will do is we will try to write what is the A1, A2 and A3 matrix for this one. Just for a information, articulated configuration is sometimes also called as elbow manipulator. It's sometimes also called as an elbow manipulator. So when you check the some textbooks, you may find that instead of calling it as articulated configuration, it is called as an elbow manipulator. So based on this, we are having the link parameter table. So now let us look at the equation required for it. So now that AI is there, with the help of the link parameter, I can write what is A1, A2 and A3 matrix. I will leave that as an exercise, as an assignment for you all to do and try to find out the answer. Thank you.